So now what do you do? Now, so your fx has been given.
Yeah.
1 second, I just.
So you know the domain.
So fx is equal to root x, okay, and then the domain has been given.
Yeah.
Has a horizontal shift of +5.
Yeah.
Correct? And
horizontal shift. Okay.
Horizontal shift, yes,
Yeah.
of +5. A reflection over the x-axis.
Yeah.
Okay, and a vertical shift of -1 in that order.
Okay.
Write in the equation of the resulting function.
So
what's going to happen?
should we first write the domain and the range?
Yeah, you can do that.
0, 9.
So 0, so domain if you're looking at.
Yeah.
So 0 is less than x is less than equal to 9.
Yeah. And the range.
Now, mate, that's just given. Now, do it.
Okay.
Horizontal shift 5.
Horizontal shift of 5. So 5. X.
So 5 plus 5, correct?
Yeah. X. And then 14.
Correct, 14.
Yeah.
So 5 and 14.
Yeah.
Okay.
Right.
Reflection over the x-axis. So nothing will happen.
Okay. So
domain won't change.
Yeah.
Vertical shift -1 unit in that order. That also nothing will happen.
Yeah. So that's
So vertical. So everything vertical reflection in x-axis won't matter.
Yeah.
Reflection in y-axis will change here.
Yeah. Right.
So this is my domain of the new function. Now what's my function? F of, so suppose you want to call it gx.
Yeah.
So what will it be?
Would you just write root
x, what is it?
X and then
horizontal shift 5 units. What is horizontal shift 5 units?
Horizontal shift 5 units. That's left
5.
Minus 5, yeah.
Reflection over the.
And then.
Right 5. Right 5.
Yeah, right 5.
But that's the function you put minus. Yeah. A reflection over the x-axis.
Minus.
Correct?
Yeah.
Vertical shift of 1 unit.
-1.
Minus
outside
1.
the square.
Correct?
Yeah.
And this you have to write along with this. Don't write. You can go home and do it. Yeah. Find a domain and range of the new function. So domain we wrote. So domain we have written on top. If you want to use interval notation, you can write this. Correct? Range.
So would you, from this, so from the original.
So see, you can think like this. This was there. Correct? Then you shifted it.
Over the x-axis.
Correct? Like this. Correct?
Yeah.
So that means this is becomes 5 and this is 14.
Yeah.
Then what did you do? This is 0, this is 9. Then you did this 5, 14.
Yeah.
Correct? And you shifted it 1 unit down.
1 unit down. Yeah.
So this 0. Now when this was 9, it was 3.
Yeah. So it'd be.
Correct. So this will be 3 only.
Yeah.
This will be -3.
-3.
And
minus
now
1 down.
-1 down.
So -4.
So that means that will come here. So it will become -1, -4. Okay. So what will the range be?
0.
-4 to -1.
Yeah.
-4 to -1.
Because you write the lowest.
Yeah, lowest first one, lowest one.
Yeah. Right.
Okay. Part C.
Find the domain of 2x minus 6.
What is the meaning of 2x minus 6 first of all? First of all, first thing you need to do is f, remove 2 common, x minus 3.
Yeah.
So what is this and what is this?
So that is a vertical stretch by factor 2.
Wrong. Horizontal stretch.
Horizontal. This is inside the bracket.
Inside the bracket. Horizontal stretch by factor?
Factor 2.
No.
1/2. So sorry. And then right 3 units. Vertical translation.
Horizontal translation.
Right 3 units.
3 units, right?
Yeah.
Correct?
Yes.
So what will the domain be? So domain, horizontal, both will get affected, correct? So that means you have 0 horizontal stretch by factor half.
0.
Correct?
Yeah. And
to the right. So that's 3, correct? This one would be 9
9.
half plus 3.
Yeah.
So that's how much? 7.5.
Yeah.
So what will my new domain be? 3
3
is less than equal to x.
Yeah,
Sorry.
I see. Yeah.
You understanding this? This is very, very important.
So you times it first by 1/2 because of the horizontal stretch by factor 1/2, and the original domain was 0, 9, right? So then you times that by 1/2, and then you plus that by 3, so you get 3. And then you take the 9, you times that by 1/2 because of the horizontal stretch, and then you add 3 because of the horizontal transition. Okay.
Part B.
Describe the transformations necessary to graph. To map the graph of fx to f. So
just now we have written it over
the
here.
first thing you
Same
take it
thing.
out,
Horizontal, yeah.
horizontal stretch factor by 1/2.
We have written it on top actually.
Yeah.
So you have to just write it formally.
Yeah.
Horizontal stretch by factor half and followed by horizontal
translation 3 units, right?
Yeah. Translation 3 units to the right.
Yeah.
Fine. So consider the graph of this. Okay, find a range. So basically what we need to do is, if you think of a graph, this is going like this. So that means if it's -1, cube root of -1 is cube of -1 -1.
Yeah.
And cube of 2 is 8. So that means the range of this graph.
-1.
Yeah.
Yeah.
That's the range of graph.
Yeah.
Correct? Part A. Part B, find a domain range of y is equal to g 1/4 x. So this is your horizontal stretch by factor?
4.
Yes, horizontal stretch by factor 4.
Yeah.
Now this is a horizontal stretch by factor 4.
That affects the
domain and domain. Yeah. So domain will become what?
-4, comma 8.
-4, comma 8.
Okay.
Range will remain unaffected.
Okay, so I do this now.
Perfect. So that means what's going to happen is this will go as -4, this will go as 8, -4 and 8.
Yeah.
So this 8, correct?
Yeah.
-4 and -1.
Yeah.
So it got stretch.
Yeah.
Horizontal stretch.
Right.
Good? You got
Yes,
it?
I got this, yeah.
Very good. The graph of this is translated 2 units to the left.
Yeah.
So if it's translated 2 units to the left,
It changes the domain.
so write the resultant equation first. What will my equation be?
I didn't do that, but
1/4 x
1/4 x
plus 2.
plus 2. Yeah.
1/4 x plus 2.
2. Sorry.
But that x you have to replace by x plus 2.
Yeah. But it means -2.
Yeah, it means it's going to the left.
Yeah, exactly.
Because the function you have to do the reverse.
Yeah.
For the horizontal.
So the domain.
This is your resulting equation. So my resultant equation would be 1/4 x plus 2 cube.
Right. Yes.
This is my resulting equation.
Resulting equation. Yeah.
Okay, and then confirm with technology that it is indeed 2 units to the left.
What I did is I just wrote
Technology
the
means
new domain.
No, you have to use your calculator
Yeah.
and check. So use your calculator. I'll use Desmos and I'll check. So if I go to Desmos. So y is equal to x cube or 1/4. We will have to look at that only.
Yeah.
0.25 x cube. Correct? That's my graph. And your domain was what? What did we have the domain? Just tell me the transform function.
The minus with the 2 to the left.
-4, 8.
Yeah, -4, 8. Yeah.
I don't remember. Is it -4, 8? I don't remember. How do you put that? No. We put box bracket -4, 8. No. I forgot how to put the domain. Anyway, It's okay, you can just do this. And we are checking now. What did you put your equation is? 0.25 open brackets x.
Oh no, that's the 0.25 minus 2 plus 2 plus 2
plus 2.
Yeah, cubed.
1 second. You are not telling me properly. You said one thing left, no? So plus 2. First you said one and then you said the other. So it's a left.
Yeah. Okay, nice.
Correct? So it got transferred.
So what would the new domain be? Would it be minus 6 comma 6?
The new domain also, if you want to write, now it's going to the, yeah. So domain would be minus 6 and 6. Yeah.
Okay. That's what
So
I did.
minus 6 is less than equal to x is less than equal to 6. That's my domain. So that's my function.
Nice.
Function. So you can write a function with the domain.
Yeah. I understand.
Okay. So fx is equal to x squared. Write a single equation to represent the following transformation in the following order.
Yeah.
Reflection in the y-axis. So when you reflect in the y-axis, what will happen?
It's minus.
X will change sign.
Yeah. So
minus x squared.
Yes.
Correct? Stretched vertically by factor 2.
2. Yeah.
Stretched horizontally by factor 5.
1/5. Yeah. This is easy.
Correct?
Yeah.
So what will it become? 2 upon 25 x squared.
Because you squared.
Yeah. Follow?
Yeah.
Graph equation technology doesn't meet the condition is correct, and you can go on. The graph of root x is given. The graph of root x is horizontally dilated, stretched. Dilution is stretched by scale factor 3. So what will it become?
1/3.
So what will it become? What should I write?
G of x is equal to square root of 1/3 x.
Yeah. So g of x or g2 of x. Let's call that, or g1 of x, some other function.
Yeah.
X over 3. Yeah.
Yeah. Yes. Yeah. Same thing.
Correct. Then the resulting graph is translated to the right 4 units.
So -4.
So what will you do?
Root x upon -4 upon 3. Yeah.
Okay. Sketch the graph of gx and perform the transformations a and b. Check the graph of this new equation that you wrote.
Yeah.
Yeah. G is equal to root x. Part A.
Yeah.
Gx is translated 4 units to the right.
-4. So g of x is square root of x minus 4.
Then B. The resulting graph is horizontally dilated.
Outside the brackets.
Horizontally dilated. So what will it be?
Oh, horizontally. So x of 1/3 -4. Yeah.
No,
1/3
different
x
from that.
minus 4. Yeah. I was thinking. It's
Only the x has to be replaced.
Yeah. Not the 4. But where did we do both? Above we did both, right?
Because first you did this and then you did this.
Okay. This time it's different order of operation.
Different order of operation. Yes, absolutely. Next. 8th one.
Compare what you did in questions.
The order was different. Yeah, okay.
Yeah.
Then next.
What is the domain of the function? Very long.
How do you find a domain?
When x is equal to 0. With this is a different.
For the domain, when you're finding, whatever is inside the root sign should be greater than 0. It should be greater than equal to 0. So this should be greater than equal to 0. Okay. Now what you can do is you can sketch this.
Yeah.
What are the roots?
-3.
-3, 6,
1.
So that means that it's a cubic function. So you have like this. So you have -3.
Yeah.
1. Correct? 6. Correct? But it's minus.
Yeah.
So that means it is going like this. Correct?
Yes.
It got reflected in the x-axis. It got reflected in x. I'm just drawing the x.
Because of the -2.
Yeah. So what is the domain now? Yeah, because minus
same domain.
So it should be greater than equal to 0. When is it greater than equal to 0?
At 1 and 6.
When is it greater than 0? When is it above here?
Oh, when it's greater than 0.
Means it's positive. When is this positive? So my domain of this will be what? X is less than minus 3, correct?
Minus 3,
so minus infinity to minus 3. Yeah? This has to be excluded. Union from 1 to 3. 1 to 6 I think.
1 to 6. Yeah, 1 to 6 makes sense. Why is it negative? Oh, because it just continues.
It continues. This is positive.
Yeah.
Good sir. Actually, a good sir.
Very good.
Are you following? So you have to know everything. So this is when you do the negative of the function. This is the positive basically, getting the roots.
So
and you put that minus sign.
You first found the roots, and then you drew the inverse of that. Or no, the reflection of the x-axis minus 2.
Yeah.
You drew. And then. Yeah.
That's it. I saw when it is positive.
Okay. Tough sounds good.
No, not tough.
I think they get tough now. Because I was looking at the back page.
Okay. Next one. 10th. So below is fx, state the domain and range. So what's the domain?
Negative infinity.
Domain.
Oh, domain. But it continues going.
No. That thing.
Yeah.
Range.
Negative infinity.
Array.
Oh, sorry. Minus 2, comma 2. Sorry, I think that.
Minus 2, comma 3.
Oh, right. Sorry. I'm being very silly.
Lowest value, highest value. Lowest value, highest value.
Right.
Lowest bottom, highest top.
Yeah, lowest
left,
yeah.
highest right.
Highest right. Yeah.
For the domain.
Right. Okay.
For domain, lowest, left, right. Bottommost, topmost.
Yeah. But I thought only if there's an arrow, then it's negative infinity, right? If there's an
arrow. The arrow. Then there's no arrow, then you don't have to. Then achha, what is this? What is this? What is this? Chalo.
Okay. Vertical stretch by factor 3. Horizontal stretch by factor 2. Vertical translation 1 unit up. RST.
Reflection, stretch, translation. So first you should do all the stretches. Or what you can do is, if you have your point x comma y, what will it become?
You can, that's how I like.
Correct. So vertical stretch.
So 2x.
Vertical stretch 3y.
Oh, sorry, talking about vertical. 3y plus 1.
Horizontal stretch.
2x.
And this is 1 unit up.
1. Yeah. I really like this.
Correct. Now what are the points? Take the points.
Minus 6.
Minus 6, minus 2. Then what is the other point?
Minus 2, comma 3.
Minus 4, comma 3. Correct?
Minus 2, comma 3.
Minus 4, comma 3. No? This would be minus 4, comma 3. This minus 4, comma 3. No?
Oh, right. Oh, the points.
Points. Then minus 1 or minus 3, comma 3 if you want to write. Suppose you take this in the center. Now. It's not very clear. So minus 3, comma 3 approximately. This point then?
So
minus 1, comma 0. I'm going A, B,
wait, I'm
C,
confused how you got
D.
minus 3, comma 3.
Minus 3,
the...
3.
Oh, I see.
So what are you looking at?
I was looking at the domain and range.
Domain range will come automatically if you take this. You don't have to worry about it.
I know that the points on the right are the translations for the domain, right? And
not for the domain, for every point.
For every point.
Even domain, range, every point. Everything.
Oh, you're just taking the points.
I'm just taking the points. Automatically that will happen.
Okay, I see.
I don't have to worry about domain and range. Because I'm sketching
it. You're taking A, B, C, and you're just seeing D. D, 2, comma 2.
Now chalo do this. So A dash will be what?
2 times minus 6.
What is that? Minus
12, sorry. Minus 11. Minus.
How?
Wait. minus 6 plus 1, sorry, minus 5. This is minus 6, 10.
Correct. Then
This is minus 2, 1. This is 4, comma 7.
now see what's the minimum x we want? Minus 12. Oh god, how will it happen? Minus 1, minus 2, minus 4, correct? Minus 6, minus 8, minus.
He said if you want, you can bring graphing paper for the samples. You can't draw the graphs.
Yeah, better it will be.
Yeah.
Because this is too irritating.
Especially
because it's too dark also.
Yeah. And the lines are very small.
Minus 10 and minus 12.
Yeah.
Correct, we need minus 12.
Yeah.
And what else do we need over here?
Minus 10.
Yeah, that's it. Actually, here we need 7. Okay, okay. But then also we will fit 7.
Yeah.
2, 4, 6, 8. So minus 12, 5. Minus 12, minus 5.
Yeah.
Minus 12, minus 1, minus 2, minus 3, minus 4, minus 2. A dash. Correct? Minus 6, comma 10. Minus 6, comma 10.
Yeah. That's it all.
That's your B dash. Correct? C dash will be minus 2, comma 1.
Yeah.
Minus 2, comma 1. And 4, comma 7. 1, 2, 3, 4, comma.
Nice. I really like this way. It's very helpful. Actually.
Yeah. So now automatically domain range was adjusted. You don't have to worry.
Yeah. Nice.
Domain range, everything got adjusted. And we got the graph also.
Good question again.
Okay, so conceptually you will get very strong.
Yeah.
And this is required for IB as well. Huh?
All these transformations?
Yeah, transformation is there for IB as well. So they repeat this concept. Because many children don't get it.
Yeah, I used to really not like it.
Yeah. But there's no choice.
Yeah.
So whether you like it or not, you'll have to do it. Okay. So perform a horizontal shift 5 units and vertical shift 1 unit. Sure.
What function is this? Is this
rational function?
Rational function.
Yeah.
So it's like 2 points, right? It goes.
A rational function like this. So you're like this.
Oh, okay, like this. Okay.
And then you go translate and all that. I'm not doing that right now. So this is a rational function. Sure. First.
So horizontal shift of 5. So x minus 3.
But 5, what did you do about the horizontal shift of 5? Nothing. You left it as x minus 3 only.
No. X, it would be minus 5.
Replace all the x by x minus 5.
Replace all the x by x minus 5. Okay, so x minus 5 minus 3. And then x minus 5, x plus 9. Oh, just plus 9. Yeah. That's what I was saying only. I was saying.
And plus 1.
Oh, yeah, plus 1.
Vertical shift.
Can you do x minus 3 minus 5? That also works?
No. It may work. It will give you the same answer, but that you should not be doing.
This is more clear.
Because if the function is different, that may not work. You have to keep in mind when you do horizontal shift, you have to replace all the x that you see in the function by x minus 5.
Okay. Alright.
It may be equivalent in this case, but other cases it may not be equivalent when other functions are there.
Okay.
So it's not a one-time thing that you're doing for this only. It's like a long-term thing you have.
Okay.
So now take LCM. X plus 4. X minus 8 plus x plus 4.
Yeah.
That's 2x minus 4 upon x plus 4.
Yeah.
That's your simplified function.
Okay. So this is the new equation?
Yeah.
Of gx. Okay.
Find a point on fx. Call it p. So what value will you take? Take any value, a random value.
2.
2 if you take, will it work? Take something that cancels out.
So in the bottom, minus 4.
Take any point. What do you want to take x as? 2 if you take, then what happens to your f2 will be 2 minus 3 upon 2 plus 9. That's minus 1 over 11. If you want to
Wait,
keep
no,
it.
won't it be, it's 2x minus 4, right? So won't it be 2 times 2, so 4 minus 4?
Which sum are you doing? fx.
Oh, sorry, I was looking at the new equation, sorry.
fx, this is fx. New equation.
Oh, so you can do 3.
3?
3. Sorry, my mistake.
So if you do 3, 3 minus 3, so that's how much? 0. Correct.
Yeah.
This looks better.
Yeah.
3. Sorry. 3 comma 0. That's your point P.
Yeah.
Part C. Translate your
0.5 units to the right and 1 unit up. So 8
5 units
plus 5, 0 plus 1. 8 comma 1.
right?
Yeah.
Confirm whether Q is on GX or not. So now you put this in this.
The original.
So suppose if you put G8, if you find it should come 1.
Yeah.
4, 8, sorry, what am I doing? 8
yeah.
minus 4, 8 plus 4,
yeah.
16, 12, correct? 12, 1, 8 comma 1, so yes.
Nice.
My thing is right for it.
Nice. I'm getting more confident actually just watching because I'm knowing how to do. No.
But what you followed how to do horizontal, you replace all the x by x plus 3.
Yeah.
Next.
Okay, this looks.
Nothing, it's the same thing. Don't go on the looks.
Okay.
Don't go on the looks. Okay. The only I don't like what he doesn't give space only to draw here.
It's really annoying.
It's annoying, in the sense that you don't know. That's a problem. Otherwise, there's no problem at all.
Yeah.
So you have this thing is too dark also, then that grid.
Yeah.
Okay.
So you have
I made it dark.
Domain of minus 2 comma 4.
Sketch a graph of minus x. Hx. This is my x.
Yeah.
So
this is translation of the y-axis.
hx. What are you saying? Translation.
Sorry. Shift, not shift.
Reflection
over the y-axis.
Don't forget the words.
Sorry. I won't forget the word. Doing happens like a random blank. That's what it was.
Okay. So now you reflect this. So this is 2 units. Correct?
Yeah.
This and this is 4 minus 4. See, I knew only something would go. Always something goes on. So that's my hx. So the red is your fx, and you reflect in this, you will get your hx.
Mr. York has already made 3 students leave his class.
Good. What a achievement. Okay. Next, part B. Then?
Let g of x equal to 1 over 2 at x minus 1.
So tell me what it is first. Well, always when this comes in, you put it down. What is it?
So it's a vertical stretch.
Vertical stretch by factor?
2 or 1/2.
This is?
And then vertical translation 1 here, right?
Horizontal translation.
Sorry, horizontal translation.
You mix some words.
I know it, but
I say you say it wrong. Right. So find the coordinates of point P. So the point A 2, 3 on the graph of y is transformed to P. So yeah. So what's going to happen is, so if your xy is there, correct? So what will that become?
1/2.
Y upon 2. Vertical, huh?
Oh yeah, right. Y upon 2. X plus 1.
Right.
No, x minus.
To the right, no?
Right. Yeah.
For the coordinates, it's the same, huh?
Right, because we're doing the reverse.
We are not doing the reverse at all. When you have a horizontal translation, 1 unit to the right, your x will become x plus 1.
Right. Yes. Oh yeah. Sorry. That's just how you write it.
For coordinates, we write like this. For function, it is like this.
Function, we write like this.
Don't confuse here. This is the point of confusion.
Okay. I'll remember this point of confusion. Yeah.
Okay.
Okay.
Now what you have is, you have A. So A is a point on fx.
Yeah.
This is A. Then it's not reverse. This is P. So if you have a is 3 comma 2, what will that become?
3 plus 1. And then 2 upon 2. So 4 comma 1.
Follow?
Yeah. This one I believe I forgot how to do. Number 13. What was this point of it like reflects over the x or y axes?
So what will we do is this, what will we do is, let's do this first. First one and then second one.
Okay.
So tell me what will you do? What is my basic function you will start with?
Square root function. Cube root function.
Cube root function.
Yeah.
Correct? We'll start with the cube root function. So you start with the cube root function. Then what do you do?
Then you
stretch.
Your vertical stretch by factor 2.
Vertical stretch by factor 2. Then what do you do?
Then you take it 1 to the left. 1 to the right.
1 unit to the right.
Yeah.
And then what do you do?
Vertical translation 2 units down.
2 units down. Then you have to mod that. Mod x.
Mod x. That's what it was. Mod x.
Now see what to do. So let's start with this. So your cube root function is like this.
Right.
So that means I'm just taking some random points. 0, 0. Correct? Cube root of 8 is what? 2.
2.
Cube root of minus 8 is what?
Minus 8, 2.
Minus 2. And the stretches. And this is just.
This is the parent function.
Parent function. Just to draw my graph.
Yeah.
Okay.
And then?
Now, when you have a vertical stretch, so what will it become?
So all those values, the range values, the y values will times by 2. So if you take.
So that means your minus 8 will become what?
Minus 8 would become
minus 4. Correct? And your 8 will become?
4.
4. And this goes on. Correct?
Right.
That's your vertical stretch. Then next one, you shift this 1 unit to the right.
Yes.
So if you shift it 1 unit to the right.
Yeah.
Okay. So 9. Correct? 9, 4. This will become 1.
1.
This will become minus 7.
Yeah.
Minus 7 will be mapped onto minus 4. Correct? And it continues. That's another thing.
Yeah.
But right now this is just for our reference. See what's happening.
And then.
Then what are you doing is?
2 units down.
2 units down. That means what's going to happen is?
The y value will change from 2 to minus 6.
So 2 units down. So this will become 1 comma minus 2.
Yeah.
This will become minus 7. Minus 7 comma minus 6. Correct?
Yeah, sorry, yeah. Minus 6, yeah.
9, 4 will become?
9 minus 2. 9 minus 6. 9 comma 6, sorry.
9 comma 2, no?
Oh, right, because you minus it by 2.
Going 2 units down, no?
Right, sorry.
Correct?
Yeah.
Achha, by the way, what will this be?
What?
What will point P be?
Is that minus 7 minus 4?
How do you find point P? How do you find out the y-intercept? Put x as 0.
X is 0, yeah.
So what will that be?
0 minus 1 minus 1 minus
What is
1.
cube root of minus 1?
Minus 1.
Minus 1. So 2 into minus 1 is minus 2.
Minus 2.
Now this is shifted how much? 2 units down.
Down.
2 units down, no? So so what will that become?
That become
Minus
4.
Correct?
Yes.
So now when you do mod of this, now see there are two things that you have to do. So now I am coming to the main part.
The mod.
So y is equal to 2 cube root so what you do is you take only the positive side
and flip it
and reflect it.
Reflect it, yeah.
You take only the positive side 1 comma minus 2, right? Minus 4 and you will do this. Correct?
Just the positive. So that is the answer for this already?
That's the answer for this already.
You don't take that other previous bit on the left side.
No.
You just get rid of that. You
Yes.
only look at the positive.
Whether your x is positive or negative, your function is the same. That's a mod x. So it doesn't matter whether x is positive or negative. So that's what you do when there's a mod x.
Okay, so let's say that there was nothing on the positive side.
Then your graph will be nothing.
Then you won't have a graph.
Then you won't have a graph.
Mod x means the positive values on the right side.
Yeah.
Shift or reflect to the left side of that.
Yeah.
Okay.
Next.
Now that whole thing is being modded. So
whole thing is being modded.
So now you keep the original function and you draw everything on the positive side, on the left side, on the negative side.
So y is equal to 2 cube root x minus 1 minus 2.
Wait, so
this will become minus 7 comma 6, correct? This will become minus 4 will become plus 4. It goes up.
Right.
This point here becomes 1 comma 2. This is your point remains the same and this is your point that remains the same. Means whatever you flip that.
I see. So modding x the whole equation causes everything to be above the x-axis.
Correct.
And then modding just x causes all the
negative
negative
x to disappear. Negative side x-axis to disappear and reflecting the positive. Please remember, very, very important.
Yeah.
Please see this several times.
Will do, especially this question.
Yeah. But anyway, this won't come.
Yeah, he's not gonna.
No, this won't come. This won't come. This won't come.
Yeah.
So good, well done.
I think I'm good for transformations. I'll be okay. I just have to